We'll begin the notes today by talking about how to divide powers with the same base. And for example, x raised to the fifth power divided by x squared has a base of x. So if we were to expand x to the fifth, it'd be x times x times x times x times x. And we're going to divide it by and then expand x squared. Then we cancel out common ones, and we're left with x to the third power. So you'll notice that considering the exponents, that 5 minus 2 is going to give me this exponent of 3, which makes sense. I had 5 x's and I took out 2 of them. So the rule for dividing powers with the same base, if we're going to not expand, would be to subtract the exponents. And here's an example. If we have this situation where we have x to the second over x to the fifth, the same type of thing happens where we're going to remove out ones, but this time we're left with our x to the third power in the denominator. So we'll say that the power was going to end up on the heavy side. So x fifth being heavier than x to the second. So my x to the third ended up in the denominator, whereas here x to the fifth is heavier than x to the second, so it ends up my x to the third in the numerator. All right, so let's do some examples. So here I have simplify 2 to the sixth divided by 2 to the second. So again, same base. So we are going to then rewrite this. We're going to keep that base, and then we're going to subtract the exponent. So that's a 6, isn't it? 6 minus 2. So that's 2 to the fourth power. Now we're going to always multiply this out. So 2 to the fourth means 2 times 2 times 2 times 2. So we get 4 times 4, which is 16. It's helpful if you memorize that 2 to the fourth is 16. Then I have x to the seventh divided by x to the fourth. So my base is x. I'm going to keep my base. I'm going to take my 7, which is the heavier one. So notice in the first one, the 6 was heavier. So I ended up with it in the numerator. Again, 7 is heavier, so 7 minus 4 is going to be equal to x to the third power. Now in example C, this time I have x to the fourth divided by x to the seventh. So the heavier one is in the denominator. So I'm going to move everything to the denominator and do 7 subtract 4, and I'm going to have to place something in the numerator here, so it's going to be a 1. So this will be 1 over x to the third power. Example C, here my heavier numbers in the numerator, so I have y to the 5 minus 4, which is y to the first power, and we won't write the y to the 1 power. That's equal to y, so you want to simplify it a little bit further. Example E, we have several variables in our expression, so we're going to combine the ones with the same base. So when I look at the m's, I have m to the second divided by m to the fifth. My heavier one's in the denominator, so when I put these together, my m's are going to end up in the denominator, and I will have 5 minus 2. My n's, when I compare them, the heavier exponents in the numerator, so my n's will end up in the numerator, and I will have, for my exponents, 4 minus 3. So that will be equal to n to the 1 power, so just n, divided by m to the third power for my answer. So example F has got something a little bit different in that it's got the coefficients 15 over 5 here. And so when we simplify this, we'll simplify these just like we've done fractions all along. And notice that 5 divides into both of these. So 5 will go into 15 3 times, and 5 will go into 5 once. So then we're going to end up with a 3 in our numerator. And then for our k's, the 6 is heavier, so I'm going to have k to the 6 minus, and if there's not a coefficient, understood to be 1, And then for my j's, the 5 is heavier in the denominator. So j to the 5 minus 2. So then that will be 3k to the 5th over j to the 3rd. Then we'll go on over here to h and end up here. This time with my fraction, with my coefficients, 2 will go into 2 once, 2 will go into 10 5 times. For my x's, my numerator is heavier, so I'm going to end up here with, got a 1 and a 5. Then we have x to the 5 minus 4. And, there's several here in there. Y, so y down here, y to the 5 minus 1. So again, I'm going to be putting like bases together. So here's my y's with a 5 and a 1. They're going to end up here. And then when I compare my z's, I see that the numerator is heavier. So I'm going to have z to the 8 minus 1. So that will give me, I don't need to write the 1 up there. I don't need to write that unless it's the only thing up there. So then I have an x to the 1 power, which I don't put, and a z to the 8 minus 1, which is 7 power. The denominator, I have a 5 and y to the 4th. So now we're ready to move to video 2.